Okay, so 19.1 we're going to be looking at the area between the curve and axis. Okay, so the other time we already mentioned that one of the applications for integration is that it is referring to the area. Okay, so if for example I have a curve, okay, and it goes by a certain equation, okay, then if I want to find out what is the area between the curve and also the x-axis, right, between A to B, in this area A itself, we'll be looking at the definite integral of the equation of the curve, okay, from A to B. Alright? It's just the way that the integral works. Yeah. Because you cannot imagine it as area. Yeah, you cannot imagine it as area. Because area is an application of it, but it's not. Yeah. Okay, let's look at try one. Okay, we want to find the area under the curve for y equals to 1 over x, where x is more than 0. Okay, whereby for part 1 we're looking at between x equals to 1 to x equals 2, and then after that x equals to 1 and also x equals to e. So to find out what is this area, we are looking at the integral from 1 to 2 for 1 over x, so that will give us ln x, which we just covered. So therefore in this case our answer will be ln 2 unit square. Ln 1 is 0. Okay. Sorry? Huh? 1 over x2, right? So it cannot be right? Is yours 1 over x? Or mine is okay. Mine is 1, my this new version is 1 over x. Sorry, let's just keep to 1 over x, okay? I have 2 copies of x. Yeah, one is O1 and one is the I did this on the O1. Yeah. Okay, never mind, let's just skip to this question, okay? Then after that, part 2, we want to actually find out the area from x equals to 1 to x equals to e. So area equals to 1 to e. Okay, so ln e itself is 1. Okay, and then ln 1 is 0. So therefore in this case, the area is 1 unit square.
Just go to the toilet, man.
try 2, we want to find the value of C given that the area under the curve y equals to e from negative x from x equals to c to x equals to 0 is actually half square units. So we want to find out the value of C. Okay, so we are given that the area is actually equals to half. Therefore, forming the equation, okay, that will be this. Okay, I think something that is missing out from this question, okay, is another condition that I want you to add in. Okay, to point out that C is less than 0. Because if C is not less than 0, then you wouldn't know how to form the equation, right? Because your C could be at the upper boundary, right? Because the upper boundary must always be larger than the lower boundary, right? So the question that needs stacking is close. So integrating the exponential function, you will get negative e power negative x from C to 0. The question says square units, so there's a normal way of writing square units. So we find that we get e to power negative c equals to 3 over 2. How do we find c? We have to bring over the what? Here we go. Negative c equals to ln 3 over 2. Okay, so you can make it in the logarithm form, okay, or else you apply ln of both sides. Right? Okay, so negative ln 3 over 2 is actually equivalent to what else? Syringe. Okay, so this is equivalent to what? Ln 2 over 3 also, right? They are the same, right? Because this is negative 1, this whole thing that power negative 1, so you can flip. Okay, but of course either answers are actually accepted lah. Any questions so far? Yeah. So let's look at try 3. We are given a sine function instead. Okay, we want to find the x-intercept of the curve from x between 0 to 3. Okay, how should we find this x-intercept? Integrate to find x-intercept. Just what? Y equals to 0, right?
Oh my god.
Okay, so sin x plus 1 equals to 0. How to solve this?
Sine inverse.
Sine inverse, then
Find the basic.
Oh my god, do we need to do the...
Find the basic angle.
Yes.
yeah.
Wait, really?
Sorry? Next was wrong question. Different question.
Wow. Dun, dun, dun.
Same one.
Same one. Sorry, what's the person? I'm just saying that. The answer for try 2, oh, you're talking about try 2, Oh. C 0. Yeah, oh, my answer here long too. So why already I count. No, like I did it by C is more than 0. Exactly, it's not right. You will see more than 0. Oh, okay, because I assume that C is less than 0. Oh, I did it C more than 0. Okay, never mind, we just stick to this question, okay?
Yes.
Anyway, it's the way of solving that I'm teaching you, okay? Not about tackling the question itself. The question will not repeat, but right? Okay?
Never know. So you never know.
I bet that you will not, okay? Okay, so let's just keep to this, okay? And so anyway, going back to part 1, okay? So sin x plus 1 equals to 0. That means what is your x plus 1 possibly going to be? 0
100
is equals to 0 only
Sign
180.
okay, remember your sine graph, okay, so it is either 0 or else pi, right? Then after that pi, right? Okay, but we know that pi is actually 3.14 something, okay, but then this is x plus 1.
So
Okay.
it's outside the range.
So actually, if you want to consider, right, 0 pi or 2 pi, 2 pi surely you will have to reject lah. Because 2 pi will actually be 6 point something already. Minus 1 will still be.
Then we 3.
Huh?
Like the graph
X-intercept has 3 1.
Oh, that's 1. What oscillation?
1 cycle. 1 period. Okay. So 2 pi is out because 2 pi will be 6 point something already. Okay, by the way, today is pi day.
Oh yeah. Oh yeah.
3
But last. Wait. What did
314. Okay. So x equals to minus 1.
Wow, really
It's really a day that's being celebrated. What?
Celebrated for what? How you celebrate? Yes, so we doing a soft.
Just I thought.
Yeah,
today we are celebrating.
Oh, that's so that day when it was 2050, it was even bigger, I think.
They will next time we just attack.
Anyway, let's get back. Okay, so x equals to negative 1 or else pi minus 1, right? Okay, so in this case, negative 1 would not be accepted, right? Okay, so actually at this point, you want to reject also can. Okay, but we are essentially working with x equals to pi minus 1.
So you have to simplify. I mean like wrong.
Okay, you do not have to leave it in decimal, you can leave it exact. Exact will actually be better because we're using it in part 2.
So you can leave it at pi minus 1.
Yes, okay. Let me just leave it in pi minus 1. Okay. Then we want to find the area under the curve bounded by this axis. Bounded by axis. Find the area under the curve bounded by the axis. Okay, so therefore looking at the graph itself, right? This is what we're seeing as the graph, right? Okay, we acknowledge that for part 1, okay, the axis, okay, the graph is not accurate, just a representation, okay, that this point will actually be pi minus 1, okay, so we're looking at the area from 0 to pi minus 1, okay, so to find out what is the area,
Area.
Huh? Cosine pi minus 1 what? Do we press in degree mode or radian mode? Radian. Okay. 1 more. Okay, we get about 1.54 units squared. Okay, I know that in your textbook you get about 2. The answer given, oh, it's not given already. Say 1.54. Okay. So what's minus times 5? Because the momentum will minus. Okay, now minus. Okay, sorry, any questions? No, ah? You want you take one. And I'm not going to. Okay, next, of course the graph is not limited to just only above the axis. Okay, the graph will actually appear below the axis as well. Okay, so we need to consider what if the curve is below the axis and how do we compute this area. Okay, so technically it is not actually about the area under the graph, okay, but it is about the area between the curve and the x-axis itself. Okay, so if we have a point A to B, to find out this area, okay, we will find that if I were to have a curve, okay, maybe if I still having a curve, right, a simple one. Okay, if I have a straight line graph, y equals to x minus 5, okay, from, if I want to find out the area between the line as well as the axis itself, right, from 0 to 5 for this area, okay, if I were to go and find the integral, divided by 2.
Integrating a straight line.
Yeah. Can you integrate a straight line?
But
You mean area under the curve?
half times.
Yeah. So if you're doing I know you can do half times base times height, okay? But what if you want to use the general idea of integration, okay? Yes, you can use Chpt's method. Okay, I'm just proposing another different method. Okay.
Yeah, evolving.
Okay, so we would get negative 12.5 in this case. Okay, if you were to do by integration, understanding what we have already, okay, we find that the area is negative 12.5. Okay, so area for rather the integral itself. For a graph that appears below the x-axis and we integrate from 0 to 5 or the interval, okay, where it appears below the x-axis, right, our area value will actually be negative. Okay, if you ask me what is the purpose and idea of having this negative value, okay, we already mentioned the area is only one of the applications. Okay, area, if you understand in your physics terms, okay, we know that our area under the graph, okay, there is displacement and distance, right, for your speed time graph, correct? So displacement and distance, what's the difference?
One is from the
Displacement is?
start of the place, starting point.
Then distance is?
Distance is just the
Distance
distance.
traveled.
Okay. That's not very helpful. Okay, what kind of a quantity is a displacement?
Vector.
What kind, displacement is what? Vector, right? Okay, so therefore what matters? Direction matters. So direction matters. So So that the direction is usually being indicated by the positive or negative sign. Okay, so that's why this negative is still important when we do our integration. Okay, but of course we cannot just do our working like that and tell me that area in this context is going to be negative 12.5. It is not meaningful for the idea of area itself. Okay, so therefore for a curve that is below the x-axis, okay, and we need to find the area, we need to do modulus for it. Okay, so that the context, that your answer is accurate to the context. Okay, so in conclusion, if you're looking for area and the curve has the function y equals to fx, okay, to find out what is the area, we will take the modulus, okay, of the integral from a to b still. Okay, so it goes by the same theory that b is still a larger number than a, okay, for the integration of fx, okay, the function of the curve. Do you understand what I'm saying?
Yes.
Yeah. Whereby we're given the curve equation to be y equals to 1 minus 1 over x squared. Okay, then after that the x-axis and the line then we want to find the area bounded by the curve, okay, and then also with the x-axis as well as the line x equals to half, and then after that also for the line x equals to 5. Okay, so the area we want to find first, alright, in part 1 is this part, and then for part 2 it is this part here. Understand? Okay, so when we want to find the one for the first part, we need to do the modulus. So therefore the area in this case will be 0.5 meters squared. Sorry? Why? How the variable complex? For this? I mean then you will be looking at the next part that will be the variable complex. As in no PRWC lah, but there is a real world context lah. Okay. Then for part 2, to find out what is the area, since that the graph is actually above the x-axis, we do not need to modulus it. No, modulus wise. The graph may or may not be provided all the time. Okay, so it depends on the question itself. Sometimes we need to know how the graph looks like, especially knowing your sine, cosine, and tangent rates. Okay, that one is expected criteria. Okay. Although I would say that most of the time the graph is provided. So we have looked at what if the curve is above the x-axis and what if the curve is below the x-axis. Okay, there are many ways for us to find the area related to the curve itself. Another concern that we would have is what if we want to find the area of a certain curve, but instead of to the x-axis, what if I want to find to the y-axis instead? Okay, so that would be another of our concern, right? Okay, so if I want to find out the area between the curve and the y-axis, okay, then surely I will not be able to integrate with respect to x. Because if you notice the upper and lower boundaries of my integral itself, these a and b values, they are found on the x-axis. If I want to find the area to the y-axis, okay, if this were to be the a and b, okay, then these a and b values are actually on the y-axis. Okay, they are y values. Right? So therefore, it doesn't really make sense if I want to integrate with respect to x. Okay, so I need to actually be doing some integration with respect to y. Alright, and in order to do the integration with respect to y, that means my equation itself must be in terms of y. Agree? So I must manipulate the equation in order to make it in terms of y, then I can do the integration. You understand what I'm saying? Okay, so I will need to transform the equation y equals to fx into an equation. Maybe let me use x equals to some function gy. Okay, so I need to transform, do some manipulation, algebraic manipulation to make it to make x a subject and then in terms of y, then I can find that the area would be that new function itself, okay, then after that with respect to y. So make sure that you are aware that this changes to dy, okay? Don't be careless and make it dx. Understand what I'm saying? Okay, so why would we need to use this? If you go on further, then we will be looking at volume. Then we need to do a double integration.
That's
Then
so you go towards the x-axis is area, then you y-axis is volume.
no, as in you double integrate, then I can become a volume. Yeah, we will be looking at the volume. Okay, other applications. 3D modeling lah, 3D modeling.
Oh, 3D printing.
the diagram for the curve. Okay, then after that, you're looking at 4 to 1. Right, and I want to find out what is this area. Okay, so please read the question carefully. Sometimes they say that the area of the curve bounded by the curve and the y-axis, sometimes it's bounded with the x-axis. Okay, so make sure that you are clear to notice which part of the area is required. So in this case, if I have y equals to 4x squared, I need to manipulate this equation to make x the subject first. So x squared is equals to 4 over y. So x is equals to positive, negative of 4 over y. But in this case, we have positive or negative, right? Whenever we take square root, we have both positive or negative. How do we decide? I surely cannot integrate in such a function. Okay, so we can see that from this graph itself, okay, my x values, right, are positive. So therefore, we only take into concern the positive square root 4 over y. Okay, so this is actually 2 and y power negative half. If I want to re-express it. Okay. So now we want to integrate to find the area from 1 to 4. So likewise, lower boundary a smaller number, upper boundary a larger number. Okay. And we're looking at 2y to power negative half dy. So in this case, plus 1, 3, correct, right? So we get the area to be 4 units squared. Any questions? Okay, so far the examples that we have been looking at, it is a straightforward application. Okay, to find out what is the area between the curve and the lines required, or in this case it is the x-axis or the y-axis. Okay, so there are times whereby the line that we have is actually not the x-axis or y-axis. Okay, so later on we will talk more about it, but let's just look at try 6 first. Okay, so we are given this diagram and the curve of the the equation of the curve that we are given, okay, as well as the line, okay, mn, having where m has a coordinate 0, 2, and then n has a coordinate 4, 0, and we want to find the shaded area. Okay, clearly at this point, okay, we do not actually have the equation of the straight line. Okay, so but we actually don't really require. We require it later on, okay? But in this case, the area over here to the y-axis itself, you can see it in 2 parts, okay? Because this part itself, this area, okay, it is related to the curve, correct? Between the y-axis and the curve. Whereas the other part, okay, it is actually the area of the straight line with the y-axis. So to find the area of the shaded region that we want, we need to sum up these two areas. You understand what I'm saying?
Yeah, again.
Bernice, are you okay?
Can I just say that
You
the curve intersect the straight line at the
at this point itself, yes. Huh? No, the question I'm saying corner. Okay. Anybody don't understand what I'm saying? Okay. Because in order to find the area, okay, it is not the area of the between the curve and the y-axis, right? Because this part itself, okay, this is actually the straight line that we've given. Whereas over here is actually for the curve itself. Okay. So that means that if I want to find the area, okay, I will need to actually find out what is the equation of the straight line. Alright? So to find the equation of the straight line, that one should be a simple task for us now, I hope.
when y is 0.
Okay, so
So you find the gradient.
find gradient. Finding the gradient
All the basic.
mn 2 minus 0 over 0 minus 4, there will be negative half. Okay, the equation of the line mm is equals to y equals to negative half x plus 2. Okay, why is it that I can straightforward? I could get the equation so easily. Because we are given the y-intercept to be at 2 at m itself. Okay? So now we can find out what is the area between the line mn and the y-axis. Can we? Really? Can we now find the area between the lines? We cannot, right? Because we need to know what is this point, right? So we need to find out what is the intercept, correct? Okay. But you need to know which one is positive and which one is negative now. Okay? Because in this case, we are going to choose the y that is positive, correct?
So why you go positive?
Cannot be what? Yeah. In this case, the curve is like that, cannot be what?
Yeah. What if it's higher?
What if it's higher?
Yeah.
The curve is above 0.
Yeah, the curve is
above x-axis.
Then you look at the straight line itself and you need to decide which is the bigger one then. Do you need the bigger one or the smaller one?
What if like that? Like not like that, like something like that. But then they only show one intercept. They don't show the second intercept.
Like that, is it?
Yeah.
Then
They never show the second intercept.
like that.
They never show the second intercept.
Never show the second intercept, is it?
Yeah.
Then you need to decide for yourself. So there's still one bigger value, then the other one smaller value, what, right? So you need to be able to decipher, right? Okay, then we will choose y equals 0.82287. So then we need to integrate. So the area will comprise of two integrals. One is integrating the straight line, which we haven't made it into in terms of y. Y from 0.827 so y plus 0 to 0.8287 y squared plus 1. Okay, do we get this integral?
Oh, so it's 82287.
Yeah, 8. Oh, 286. Then we now integrate 4y minus 2y squared over 2, 0.82287 plus 2y cubed over 3 plus y 0 to 0.82287. Okay? So if you have left your answer in exact, then you could keep it exact. But in this case, you could actually leave it into decimal, it's fine, right? So, yeah, should be inside. Okay, so 4 times 2 minus away.
You put exact form, but you won't give the.
Yeah, it should be. Yeah.
You can just use the sign from both and significant figure.
Yeah, I'm not particular about that sign. And use equal sign also.
Because I'm confused since primary school they always tell us
Truncate, my habit is truncate, I use curly sign. Estimation, approximation, I use curly sign. When I leave my final answer, I put a equal sign and I indicate that it's a 3SM. You can also put a curly sign, it's fine. There's nothing wrong with that. Okay, you go and count yourself, okay? Then we get 2.58. But actually, is there alternative? After we do so much.
Why you like this?
Is there alternative?
Triangle can have the base.
Correct. Okay. This is a triangle, right? Half times base times height.
Wow.
But because they told we also need to do this one.
Wow, feel very loud already.
Okay,
Okay, any questions?
Entire paper gone through already.
So what was the height? Later the checkpoint is.
Huh? Then you need to find x. Okay, if you want to use half times base times height, then you need to find the height. Alright?
Unless you
Any questions? Are you all okay? I know it's a lot to process. Okay.
oh my god, my cell is like why
everything
Line up, they'll ask you to identify the project. They'll ask you how to line up, they'll ask you to
never ending cycle.
12 mark question, you just yes.
Last time we used to
Shall we do one more?
No. Like without being the chapter, we can still do a lot of exercise.
Oh, 19.1. You want me to give your homework for 19.1? Hey, 19.1 homework.
I got sick of myself already.
On 26th of March, Tuesday,
Teacher, you haven't finished yet, right?
Hey, you want to do long holiday or you want to do like 2 days?
Huh?
You want to do long holiday or you want to do 2 days?
are you sure that you have a holiday?
We would like to think we have a holiday. Please stop crushing our hopes.